All right, so we are moving on to session 3 for lesson 12. We're still adding fractions, but now we're using mixed numbers. And our warm up today shows us how to get those mixed numbers from these fractions called improper fractions. So, what we have here is we have a larger number on top than the bottom number, and that's the same for all three of these. And what we can do is understand that if your number on the top for a fraction is bigger, it means you can take out at least one whole from that because fractions, again, are parts of a whole, equal parts of a whole. So let's look at this first one. If I look at my 7 over 6, I know I can get at least one group of sixes out of that 7. So I've got one for my whole, and then I have 1 6 left over. For this one, I can still get one whole out of there, and then 11 minus 6 is 5. So I get 1 and 5 6 left over. And for 8 over 6, I know I can do a couple things. I can get one group out of there, and then get 2 6, and I can reduce that to 1 and 1/3. Or sometimes what people will do, and I'll use the space here to show you, you can, you can actually reduce your fraction before you convert it to a mixed number. And I know I can get one group out of that and 1 and 1/3. If you notice that, you're going to have to, if you're going to reduce and can see it ahead of time, you can do that step in the beginning or at the very end. It just depends on what you want to do. All right, so let's get started. It's on page 237. And um, a lot of the work you're going to be doing for IXL will not involve mixed numbers today. What you'll be doing is adding fractions with unlike denominators. I think they need a little extra practice with that. And then our following lesson will be adding mixed numbers and fractions. And that will actually be for, again, the next lesson. And we'll have some more practice with that. So this is basically a preview for the next lesson as well. All right, so here's our question. Jenna spent 1 and 2/3 hours mowing the backyard. After taking a break, she spent 3/4 of an hour mowing the front yard. How many hours did she spend mowing the whole yard, or basically the front and backyards? Well, we have the backyard first. So let's add that 1 and 2/3 and the time she spent mowing the front yards. So there's 3/4. And what you notice right away is we have different numbers in the bottom here. We have unlike denominators. So the quickest way to find a common denominator is to multiply them together. And that gives us 12. And if I'm going a little fast, don't worry, we'll break down all these steps on the next couple of pages. So now what we have to do are take these fractions and we need to create equivalent fractions. So take your 2/3 and that will equal something over 12. Well, I know 3 times 4 gives me 12. So 2 times 4 is 8. For the 3/4, I know 4 times 3 is 12 and 3 times 3 is 9. So I've got that. So what we have here is we have 1 and 8/12 plus 9/12. That gives us 1 and 17/12. So as you know, with our warm-ups, they usually kind of are directly related to the very first problem we do. What you probably notice here is the 17/12 is our improper fraction. So what we can do is we can do this. This can equal 1 plus the 17/12. And well, let's find some space here. I'm going to take my 17/12 and we're going to convert that to a mixed number. So I can get one group of 12 out of that 17/12. That gives me 1 and 5/12. So this equals 1 plus 1 and 5/12, which is 2 and 5/12 hours. But I know And that's what we got for that one. So a lot of steps there. That's why, again, we'll just take these step by step. All right, so go ahead and turn the page. All right, so we've got a couple different ways that you can solve these problems. The first one here is using models, also using pictures. We've got right here in red, we have, this represents how much time was spent with the backyard. And over here in blue, this is what's going on with the front yard. So we can visually see that she spent more time doing the backyard than the front. This is represents 1 2/3 hours, and over on the right is 3/4 hours. Now we know that both these need to be broken up into equal sections, and we already did that by finding our common denominator of doing our 3 times 4 equals 12. So hopefully this helps us understand why a common denominator is useful, because what we have down here is we've got a group of 12 and we've got a group of 12 right there. This is 1, 2, 3, 4, 5, 6, 7, 8, 8/12. And this is 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 9/12. And if we added those up, we would have 1 and 17/12. But we know that that's actually 2 and 5/12 because we converted this mixed number. All right, so that's one way to do it. Draw a model and figure that out. You can also do the number line, and this number line is divided into thirds and then twelfths. Um, these are the thirds with the red lines here. So everything that has a black tick hash mark, that is the twelfths. And what it does, it takes our starting point, our 1 2/3, where she had mowed the backyard, and then we go up until we reach 2 and 5/12 right there. But again, not a really practical way of doing it. And again, the hops right here, there, that's 3/12, 3/12, and 3/12 to get our 2 and 5/12. All right, let's look at our questions on page 239. All right, look at the models on the previous page. What's the common denominator of 1 2/3 and 3/4? Figured that out as 12. You can find this common denominator without a model, which is kind of what we've done already, but let's talk about it. Write a multiplication equation that shows how the denominators 3 and 4 are related to 12. It's pretty simple. 3 times 4 equals 12. Use this common denominator to find equivalent fractions for 1 2/3 and 3/4. So we did do that. But over here on the right, we want to change 2/3 to an equivalent fraction with 12 in the bottom. So 3 times 4 would give me the 12, and 4 times 2 is 8. 4 times 3 is 12, so 3 times 3 is 9. And that gives us 1 and 17/12. And for 4, the fractional part of the mixed number in the problem 3, this is problem 3, is more than 1. How could you rewrite the mixed number so that its fractional part is less than 1? Well, that gave us 17/12. We know, looking at this, we can get at least one group of 12 out of there. So this is 1 and 5/12. And that gives us that. So how many hours did Jenna spend mowing the whole yard? And that would be 2 and 5/12 hours. And explain how to add with mixed numbers. We would, let me see if I got some space here. Rewrite the fractional parts, excuse me, with common denominators. and then add the whole numbers. In most cases, you'll just have one. Sometimes both will have mixed numbers. For today's example, we just had the one mixed number, but we created an additional mixed number by adding up both of the fractional parts. So that will happen. It just depends on the situation and the numbers involved. All right. So as always, skip 6 since we can't really have a discussion about that. And let's put this to work. Okay. So what is the sum of 1 and 1/6 and 2 and 3/8? Show your work. Well, this is the work we're going to be doing here. We're going to deal with 1/6 and 3/8 since those are have unlike denominators here. We have to find a common denominator. Now we could go straight into it and we could just multiply 6 times 8 and give us a denominator of 48, or you can find a smaller one, which gets rid of our step for reducing by listing the multiples for 6 and 8. So that would be 6, 12, 18, 24, 30. And then 8 is 8, 16, 24. And I'm going to stop right there because I've already made a match of 24. Okay. So now we know our common denominator. So let's put 24 here. So 6 times 4 gives us 24. 1 times 4 gives us that, 4 over 24. 8 times 3 gives me 24. 3 times 3 is 9. So there are my fractions. Okay, so let's not forget about our whole numbers up here. So this is actually 1 and 4/24 plus 2 and 9/24. And we will just add up our whole numbers. 1 plus 2 is 3. And then 4/24 plus 9/24 is 13/24. And there is your answer. And we don't have to reduce, we don't have to convert anything. That is your final answer for that. Let's look at 8. All right, Cameron has, all right, this is an interesting problem because you're adding 3 things, but I'll kind of get into why we shouldn't panic over this one. All right, Cameron has 4 3/4 pounds of raspberries, 2 1/8 pounds of blueberries, and half a pound of blackberries to make a fruit salad. So we've got that, and that. How many pounds of fruit does Cameron have in all? So again, like I said the other day, when you see that phrase "in all," that's your cue to add. So let's put all our numbers down here so we can see them together. 4 3/4 plus 2 1/8 plus 1/2. And looking at all of these denominators, these bottom numbers, I know we talked about how sometimes you don't have to change every fraction. Sometimes you only have to create equivalent fractions for different ones. I'm looking at that 8 right here, and I know that I can do stuff with the 2 and the 4 to make them an 8 to change up my fraction. So let's start with this first one. So I know I can change 4 3/4 to 4 6/8. We're keeping 2 1/8. And the 1/2, if I multiply 2 times 4 and 1 times 4, that gives me 4/8, just like that. So all my denominators are the same. So now I can get to work. So I've got 4 plus 2, which is 6. I add up my fractions. 6/8 plus 1/8 is 7/8, and 7/8 plus 4/8 is 11/8. And what this actually is, this can be 6. So since we have 11/8 here, we've got to figure out what this mixed number is, since that top number is bigger. And I can get one group of 8s out of that and have 3 left over. So this is 6 plus 1 3/8. And the grand total is 7 3/8 pounds. There you go. And let's look at the last problem. All right, so another one where we've got this. Let's write down, we've got 5 3/5 plus 4 1/15. So again, we don't always, if we take a look at these before we start working on them, we can see I've got a 15 here and a 5 here. With that 3/5, I can create an equivalent fraction and then leave the 4 1/15 alone. So 5 3/5 will become 5 9/15. And then we keep the 4 1/15. We add up our whole numbers, 9. We add up our fractions, 10/15, which is, we can keep this answer, or if you notice that we can reduce, because a 5 will go into the 10 and 15. That gives us 9 2/3 as a final answer. Okay, so that does it for this lesson. Again, we'll be doing more with the next lesson and adding mixed numbers and fractions together. So then our homework will be like that. For today, I wanted, again, just to focus on adding mixed numbers with unlike denominators. That's actually not the one I wanted. All right. This actually should be something else. All right. This actually, what this should have said, I'll just do it this way. This is what happened when I do too many things at once. This should be, there we go. Let's go with L8. And it's add fractions with unlike denominators. Add fractions with unlike denominators. I guess only the people that actually watch the video this far to the end will know that I screwed up. So we'll keep that between us. There you go. So L8, L19 is going to be the one you do for the next lesson. So that's that. If you have any questions, let me know. Thank you.